Here's a video to show the Starbucks data in Unit 4. On page 100, we're asked to use the linear regression equation to find the prediction and the residual. So I've input the years since 1990 and the number of Starbucks. And so if we go into Stat and choose Regression, Simple Linear, our X variable will be years since 1990, and our Y variable will be number of Starbucks stores worldwide. We can ignore the hypotheses tests and go ahead and just make sure it's got the fitted line plot chosen and compute. And so we're given here the slope and the intercept. And if we scroll to the right, we see here's the plot of Starbucks stores and here's a linear regression fit. If we hover our mouse over the line, we see the equation written in its more usual form that we're used to. Y equals in this case they put the starting value first, negative 1105.6571 plus 488.11209 times x. So the slope here is the 488. So it's saying on average 488 Starbucks stores were added per year. This doesn't look like a great fit. In part, it starts at a negative starting value, which we know doesn't make sense in terms of Starbucks stores. And when we look at the fit, we see low values. The line is below lower years, and the line is again below for higher years. And in the middle, the line is an overestimate. So it doesn't look like a great fit. So we're going to go into, let me just shrink this down. Okay, we're going to come over to variable 3, and for variable 3, we're going to title that prediction, and we're going to go ahead and build the prediction from the regression equation. So we can compute expression, and we're going to build our expression, and so we'll start with the equation as given, the starting value, 1,105.6571. And then we'll say plus 488.11209, and then we're going to multiply it by years since 1990. So we'll click that in columns and select add column. We'll say OK. And then column label, I already labeled it prediction, but you could add that in here if you wanted to change the name. And we compute. Oh, and it gave it over here since I'd already started another column. So let's see, we can go ahead and delete this column here. Or come over here. Okay, and so now for variable 5, we want to do the same thing. We'll go to data, compute, build our expression. So if we go into build, this is going to be our residual, so it's going to be the observed minus the prediction. So the observed value was the number of Starbucks. So we click number of Starbucks and add column. And then we'll subtract the prediction. So we highlight prediction and select add column and say OK, and then we'll name this column the residuals. And we'll say compute. Oh, I put it in I bumped it over a column again. So here, these are the values that we'd fill in on page 100 for our chart. And then we want to go ahead in question 2 and think about, well, what does the residual plot look like? So if we go to graph, our x variable and our y variable can be the residuals plot. And we see here, if we look at this scatter plot, have a pattern. It looks almost like a parabola. So when the residuals have a pattern, that's a situation where it's a bad fit. So it's telling us the linear regression is not a good fit for this data. And if you notice, the positive residual values here correspond to years 0 to 2 and years 10 to 13. And then the negative residual values correspond with these middle the trend. So seeing this pattern in the residuals is telling us that it doesn't look like the linear regression is a good fit. So question a readily discernible pattern to the Starbucks residuals data, and so you say it looks like a parabola or a U shape.